Good evening, my name is Amit. In this video, I'll be demonstrating about the implementation of neural network and decision tree, as well as the various concepts associated with it and the interpretation of results in SAS Enterprise Miner. So to start with, for this experiment, I have used the glass identification dataset, which has 9 input variable and 1 target variable. So this is refractive index, and these are the different metals, and this is basically a type. So for example, this stand for the Windows glass of type float, 2 stand for the Windows glass for type non-float. So similarly, these are our data side. So to start with, as I have already implemented all the steps in SAS Miner, which I will be explaining step by step. So for the first, we have created a diagram. So glass data. So basically I have used this file import to import our data set, and then this is a stat explorer node. This is used to, this basically gives the statistical summary of our data. Here we can see this is the statistical summary of the data. It gives all our statistical parameters. Now this is the very important node data partitions. So here we have partitioned the data in training, validation, and test. And training, I have, as we know that I have trained my data, 75% of data I have given to training data sets, so that so that my model will be good, and the remaining 25% I have put on the validation and test. Once training in data partition done, then I have use the control points. So this is basically used to connect to the multiple model, so that we can work with the same data set. And now first I have taken this neural network model from this model tab, and as we click over here, we can see in this tab. So when we click on the network, we can see this parameter. So here comes with the first important concept, that is representation. As you can see over here, I have selected the architecture multi-layer perceptron, and the number of hidden units 5. So the input layer is fixed, the output layer is a target variable. So according to the number of hidden units, the representation and the structure of the neural network will be changed. The more the number of hidden units, the more complex the neural network will be, and normally if we increase the hidden units it will give more accuracy. See, so this is the representation concept associated with this. Now the second important concept is the optimizations. So as we click over here, we can see here, so the training technique. So as we know, in the main goal of optimization is to our goal is to find the best way to minimize the error, and for that we have to adjust our weight, and to gain this, to achieve this, we use one algorithm called backpropagation algorithm for optimization. So that's why I've selected backpropagation, and then this is a maximum iteration I have kept to 35, maximum time to 30 minutes. As we go down, we can see here, this explains the third important concept, that is hyperparameters like learning rate and momentum. So learning rate basically tells about how much weight we should change each time, and momentum tells us about the tendency of weight to change in same direction. Normally we keep the momentum between 0.5 to 0.9. Now so and normally the learning rate, we prefer the decaying curve in learning rate. So these are the two important hyperparameters concepts in neural networks. So this explains our third important concept. Now after running this model, when we run this neural network model, we'll get the results of neural network. So this basically is the results, and here the graph, this is the graph. Here we have this cumulative lift and the gain curve, and this here we can see the comparison between train and validate data. Now these explain our fourth concept of evaluation. Basically this gain and lift curve is used to used to evaluate the effectiveness of our model. And unlike the confusion matrix, this cumulative lift and the gain curve is used to on the portion of sample of data instead of the whole sample. And uh, and the more the area between the lift curve and the baseline, the better the model will be. Similarly, this explains our the concept of misclassification rate. So lower the misclassification rate, better our model will be. And this is the mean square error, and mean square error basically we use to avoid the absolute error, which is unnecessary. So this explain our fourth concept of how to evaluate our model. Now this is the output output of our neural network. So here we can see the the weight and hidden layer created by our model, and these are the fit statics associated with our neural network classification table. This tells us about the false positive, false negative, and those parameters. So now the second algorithm we have implemented is decision tree. As you can see here in decision tree, I have set the splitting rule. I have set the splitting rule to leaf size 5, 10, and over here 5. And when we see the results of the decision tree over here, so over here we can see this is the decision tree created by the graphical representation. Here we can see the important parameter is the magnesium and the refractive index, and once and these are, as you can see, this is the leaf statics. And when we see the output of our here, the one of the very important parameter is the variable importance. Here the refractive index is considered very important variable, as it has one importance. And then this is the leaf report. You can see over here, this is the depth is not in sequential order, because the algorithm will automatically do the pruning. For that, the depth is not in sequential. And then these are the classification tables and assessment scoring based on the depth. Now at last I have used the model comparisons. So model comparison basically compared two different model, and the output of my model comparison is shown over here. And over here you can see the misclassification rate is lower for the decision tree. So we can see for this data set the decision tree is better.